It is an honor to be able to appear before you today to discuss the national energy infrastructure and its vulnerability to extreme weather events and climate change. The U.S.'s energy infrastructure is extraordinary, both in the scale and complexity, and this vital network is susceptible to climate change through two phenomena which have already been outlined by other panelists, that is, the vulnerability to storms and the long-term climatic conditions. I'd like to focus on a couple specific examples to illustrate this, and carrying on the theme of Senator Craig, we do have an infrastructure which is quite aged. And if we look at some of that infrastructure and the challenges that it will face, particularly with climate change, we have some decisions which need to be made. The national laboratories have developed infrastructure models to assess the vulnerabilities to domestic infrastructures, and these models are already in wide use within the federal government to improve our ability to prepare for and respond to natural disasters. But let's look at these specific examples, maybe away from the coast, where some of the other panel members will concentrate their testimony. I'd like to take an example of California. Using climate science to predict the temperature rise in coastal California, we can evaluate the cascading effects on the electric grid and water availability. The midpoint prediction for a rising temperature in California by the year 2030 is on the order of 2 degrees Fahrenheit. Although this seems like a small number, it will have a dramatic impact. For example, the length of the season for what we call heat wave days grows by about 30%, and further, the demand for electricity will create rolling blackouts. And if we put those together, we see that this will increase by approximately 11 gigawatts of new power capacity that's required just to deal with the climatic changes. This is above and beyond the nearly 60 gigawatts that will be needed for projected growth to California's state economy. Beyond these power needs, there's a connection to water. And meeting the increased power needs, if it's, for example, use coal, will require an additional 280 billion gallons of water per year. So in this California scenario, even a slight temperature change will require maybe a 20% increase in new electrical energy capacity, have a dramatic impact on water resources, and together this will have a consequence on the California GDP on the order of $20 billion, or $200 billion by the year 2030. A second example I'd like to show, which are illustrated over here, is the consequences of shifting to renewables, in particular wind. There's a new wind study that's out today from EERE. Wind provides a clean but intermittent source of energy, and if we consider an energy scenario where we want to see wind to grow to be 25% of the portfolio in the western U.S. region, we can look at the consequence. Wind generation capacity must be installed in geographic areas that we have sustained wind resources, and on this chart you can see those are concentrated in the western U.S. on the eastern slope of the Rockies. Getting to a goal of 25% wind generation requires adding something like 20,000 square miles of wind generation. However, this wind generation is far from the existing grid, and it will dramatically overload the existing grid as it carries power to our population centers. And this is illustrated here. The dark blue lines show you where we will have transmission overloads. So simply increasing the wind power is not sufficient to talk about what the climatic changes will have. These scenarios illustrate that there's significant trade-offs in the different choices we need to make when we look at a growing energy portfolio. Climate change provides a set of future constraints with measurable economic impacts. They nearly have as much impact on our energy choices as will our growing population over the next 30 years. So in conclusion, I just want to give a few of these examples where the national laboratories are applying science to understanding important vulnerabilities and trying to provide choices or scenarios that public policymakers can make and when they make choices for energy. So I thank you for this opportunity for testifying, and I'm pleased to answer any questions you may have.